This is a video on how to write a very lightweight copy version of the Unix copy command CP. So if we go into the 212 directory, I've got something called like check2e, and here's a file, and then I could copy it to make another file called check2f, and I've run this command CP, and then if I look at check2f, it's identical because we made a copy of it. So we're going to make a program that does that. So we'll call it cp.c, and we're going to need the standard IO library. Maybe we'll need some others. And we'll have to do this thing where we take in arguments from the command line. So here's argc, which tells us the number of arguments that were executed at the command line, and here's argv, which is each of the strings. And see, I've already messed that up. Often you'll see it like this, where it says, and so when I look at this, this says it's an array of pointers to characters, and of course a pointer to a character is a character string in C, so it's an array of character strings. I don't like putting arrays in arguments because I don't really know what C is doing underneath the covers. I know what this means, and that's actually what's happening underneath the covers. So we'll add some print statements. So what we'd like is when we invoke our copy command, it's going to be copy file1, file2, and there's going to be, so this is 3 arguments. The name of the executable is one of the arguments, and then this is the second argument and the third argument. So we're going to say if argc does not equal 3, then and we're going to use, remember we talked about error streams, and so we're going to use the standard error stream, which will always print, and it's the appropriate thing to use because that's it says that there's an error here. And so we'll just say usage %s file1, file2, and then we can actually pass in the name of the executable. So you see, I like to always, and then we should exit, right? When you have an error condition, make sure you remember to exit or do something rather than just issue a print statement. And we need standard lib to do that exit. So now let's test it. Right? Remember I was saying in class you should test your code as often as you can. Here we've done something that we can test. So I'm going to go to the 212 directory. It compiled, and then if I say a.out, it says usage. And you see it knows its name is a.out because we passed in argv of 0 as the name of the executable right there. If we'd done gcc-o and we call this my copy, cp.c, so -o sets the name of the output. And so now instead of compiling it to a.out, it's called my copy, and then we run my copy. Now it says usage my copy file1, file2. So the name of the executable right there is being passed in as argv of 0. And if we were to do this, then it would run successfully. If we were to do that, then it would again fail because we have too many arguments this time. Of course, when we do this, when I said it runs successfully, all that means is this if test didn't execute and it got to doing, well, nothing. But we'll make it do something now. So we want to do file IO. So we'll make a file pointer, which I'll call fn, and we'll do an fopen, and we're going to read argv of 1, and we say we want to read. And the big thing here is we want to check to make sure that it doesn't return null. So if the file we pass in is not a real file, then this fopen command is going to return, instead of a pointer to a valid, and this is a file struct, a pointer to a valid file struct, it's going to return the null pointer as an indicator that nothing happened, and or that it wasn't able to open it. And so we should be checking to see if it's null, because like the next thing we want to be doing is we're going to be doing freads and stuff like that. And if we're doing an fread, and an fread will take fin, this pointer to a file is one of its arguments, if this is a null, fread's going to plow ahead and crash because it's going to be trying to read from a null file. And so we should be checking right here to make sure that it's not null. And by the way, I'm filming this after I filmed lecture 11 on images, And so in the starter code for Project 2G, I did add some checks to make sure that the file actually exists. So you don't need to check for it in your read image function. Okay, so if it is null, then we want to say, look, I'm going to go up here and so I'm in command mode. I'm using VI 2YY, and so that's now yanked 2 lines, and then I go down and I say P to paste, and then I'm going to add a new message, which is could not open for reading. And so now we've got more code that we could test. And so we're going to compile this. And if we run my copy and say we want to read copy.c, an output, we get nothing. But if we give it some bad file and an output, then it says it couldn't open bad file for reading. So it seems like we got this part right as well. Now, of course, this is the trick, and I did some of the lecture on this trick, because what we'd like to do is an fread. So let me do a man on fread. So fread, I always get the syntax wrong. Fread, we want to read into a buffer, and so the typical way to allocate a buffer in C is with unsigned cars. And so I'm just an array to store a bunch of bytes. And so we're going to want something like this, which is data, and we want to say malloc, and then size of unsigned car, which is 1. That's kind of the point, but we still do it just to write clear code. And then this is the issue, is we don't know how much to allocate. And so we'd like to do an fread of the data, and its size is 1. And again, how many? So it says, here's the syntax. You read into a location, that's data. Then the size of one element, well, the size of one element, I see I put 1, would have been clear if I would have put size of unsigned car. And then, in items, and so we don't know what that in items is. So let's just make an int which says in items. And so that's really our problem, is that we don't know how many items we need. So we can almost read all the data in. See, this code right here will read in all the data from fn. The problem is that it only really reads in all of it if we know how many items to read, and we don't know. And so that's why we needed this trick where we did an fseek, because we had this thing about the file position indicator, and if, let's see, I'm trying to get this right for the mirror image. So it starts at the beginning, can I get my hands oriented right? At the beginning of the file, and then every time you read, it advances. And what we want is we want to put the file position indicator at the end of the file, and then we want to say, what's your position? And if there's 1,000 bytes and it's gotten to the very end of the file, and we ask what's your position, it would be 1,000. And then we say, aha, there's 1,000 bytes in the file. And so we can do this trick with fseek, where we can do an fseek. See, here's so I did man fseek and showing me the form of the function. So an fseek on fn, and then we go to have an offset of 0 from seek end. And so this says go to the end of the file and have an offset of 0 from the end of the file. So seek end says set the file position indicator to be relative to the end of the file, and how much of an offset should you have? Well, we could have said -10. We could have also said +10, but +10 wouldn't make sense because it would be beyond the end of the file. And so we know the valid options are seek set, which is the beginning, and seek cur, which is the current position, and then seek end. And so, for example, if for some reason we read 4 bytes, and then we want to read them again for some reason, we could do an fseek from seek cur and go back 4 bytes. But what we want to do here is we want to do a seek from the end, and then we're going to set in items to be at ftel of fn. And so, oops, and let's just do a man on ftel, make sure I have the syntax right there. Looks like ftel is really easy. And then, again, we're not even going to do the read here. Let's just make sure we got this right. So, number of bytes in %s is %d, and number of bytes in argv of 1 is in items. So now, we'll go over here, and we will compile again. Done something. It says warning. So we've done a comment within a comment, but I actually don't see where I did it. Does that help? How embarrassing. That does help. I'm not quite sure what I did wrong there. I'm sure that I had something like oriented the wrong way or something. Anyway, if we say my copy for copy.c and then file 2, then it says the number of bytes in copy.c is 639, and if we do an ls-l on copy.c, that it says there's 639. So that's good. Again, I'm really trying to make the point here to compile and test as often as possible, because it's one of those things that when it worked exactly how you expected, you say, oh, I wasted a little time to do extra compilation and run the test and add print statements, but when it catches there's a problem, that's worth its weight in gold. So now we're doing this read that we already implemented, and then we do the other side of this, where we say fout equals fopen, and in this case argv of 2, and write, and we say if fout equals null, and I'm just going to go up here, and now I'm going to do a 3yy, so I'll get the closing brace, could not open for writing, and then it should be pretty straightforward. We're doing fwrite with yyp, fwrite. I did, by the way, a chain CW. So you see it says fwrite, I'm pressing CW, change word, and it removes the current word and puts you in insert mode so that you can replace it. And then I typed READ. I actually don't want that, so I'm going to press U, and U does an undo. And you can see down there it says, this is the change before some numbering system that it's keeping track of that means nothing to me, and it says the last change I made was 11 seconds ago. And then I have a problem that I'm saying I want to do an fwrite to fn, but I actually want to do it to fout. And then I go ahead and do fcloses on fn and fout, and I think we got it. So we're going to compile it again, and we'll say my copy, copy.c to copy2.c, and if we look at copy2.c, uh-oh, that looks good, but copy2.c sure doesn't look good, does it? I sure hope I don't have to refilm this video. Fout, write data, size of car, and items to fout. This would be where it would be really useful to have the class and someone can say, Hank, you made this mistake. Well, I did the same thing. It gave me the same incorrect thing. Here we're doing an fread from aha. So here's what's gone wrong. I did an fseek, and I went to the end of the file. So the file position indicator was here. It got moved to here. I did an ftel. I had to set it back, and I forgot to do that. So let's go ahead and set it back. And now, if we compile, and we look at cp2.c, we now have a copy. And if I go to cp2.c and I take out all the lines except for that one right there, and I do a chmod to say that it can't be written, and I run it again, then it says it couldn't open up CP2 for writing because we didn't have write permission to that file. So I have this here, and this was what I had in the slides, and you can see in the slides I did a better job in terms of putting the variables at the top of the function, which is technically what the C standard is, although all compilers support declaring variables as you go, as I did in my implementation here. We're checking for argc of 3. We do an f open. It looks like mine, I'm checking to see if it's null. That didn't happen here. Here was the key line that I missed, and then allocating a buffer, reading from it, opening, writing, and closing both, and I didn't have a return 0 here. But it looks like I did pretty close with one mishap. Okay, I hope everyone found this useful. Bye, everyone.